In this section, I would talk about the best practices which help you improvise your programming techniques. Best practices: class and instance members. If you want to call a method of a class without making an object of the class, make the method static. Also, ensure that such a method does not directly affect the state of a given object. Static methods should only implement the generic behavior of a class. Use static to define constants so that their value can be retrieved without making an instance of the class. If constants are not made static, they would occupy more memory, because each object would have its own copy of the constant value. In most cases, this does not make sense. Make used objects eligible for garbage collection. This helps in releasing the memory effectively and also improves the performance. Accessing local variables is faster than accessing class variables because they belong to the same stack. However, if the state of an object is to be changed, you will have to use the class variables. Best practices: constructors. It is always a good practice to add a no-argument constructor to your code. The first statement of every constructor should be a call to the preceding constructor of the same class or a call to the superclass constructor. It is good to keep the attributes common to the features of the class in the default constructor, rather than making new attributes at all places and assigning them values. Best practices: inheritance. Override and customize methods from a generic base class to have enhancements as per your requirements. You can go for inheritance when you find the need to fully or partly customize a given class. For example, savings account class needs to partly customize the behavior of class account. The best way to access a superclass method from a subclass with the same name of the superclass method but different functionality is to use super.methodName. Avoid inheritance as much as possible, unless there is a real relationship visible. Inheritance violates the rules of encapsulation. Avoid inheriting long chains as it involves calling all the parent constructors all along the chain until the constructor for java.lang.object is reached.